Okay, in today's lesson, we're going to look at the modulus function, or what you might commonly known as the absolute value function, if you've seen this in your Algebra 2 class. So I have my little dictionary at the top, which just reminds you that the modulus function is your absolute value. So just make sure you're aware of that word. And today we're going to do three things. We're going to solve a modulus equation. We're going to graph a modulus function, and we're also going to graph two special things, the absolute value of f of x and f of the absolute value of x as well. Specifically, the textbook says that we're going to do these things, and obviously some of those you just saw in the objectives that I just stated a second ago. Now, this should be covered really in Algebra 2. I put a reminder there, check for extraneous solutions. When you solve an equation, you should always plug your answer back into the original equation just to make sure you get a true statement. So for questions like this and the lines tell you that this is the absolute value, remember also what absolute value does. It makes something that's negative positive. If something's already positive, then it will just leave it alone. So when we have a question like this, and I listed it on the side here, when you have the absolute value equals something else, so in other words you have the absolute value just by itself, then you just split the question into two things, one being 11 and the other thing being negative 11. The reason we do this, of course, is the absolute value of negative 11 is 11. You then solve each of the equations independently and just check to make sure. Plug in these numbers. Once you have your two answers, plug them back in just to make sure you get a true statement. For this one, we did get two true statements, so both answers are correct, but it is possible you might get one where it's not true. Now, the one that you should try then is this one here. The absolute value of x plus 7 equals negative 5. Pause the video, and after you've had a try on that, let's have a look at what answer you had for that question. Now, I've got to admit, this one is a little bit sneaky. If you did exactly what I just told you, you would have split this into two separate questions. You'd have had one being a negative and one being a positive. You would solve each equation independently, and you'd come up with your two answers. Now, if you check those two answers, though, you're going to find that that does not work. Negative 12 add 7 is negative 5. And when you do the absolute value of that, you get 5. You don't get negative 5. And negative 2 plus 7 is 5. And the absolute value of 5 is not negative 5. So no, this question was a big joke. The problem was on the first step. Remember, the definition of absolute value is it can never equal something that's negative. So for this question here, this one would just be actually no solution straight away. So keep an eye out for a question like that. It doesn't come up too often, but I thought it was worth mentioning. Now, for questions like this, you can't split this into two straight away, and that is a problem people do. They'll often say it equals 9 and it equals negative 9. We can only do that when we have the absolute value by itself. So let's start rearranging this equation. So I subtract 1 from both sides. I divide by 2 from both sides. And now I've got the absolute value by itself, and then you can just follow those steps that we did before. Notice it is positive 4, so we can split this into two. So 1 equals 4, 1 equals negative 4. Solve each one independently, and then plug those answers back in just to make sure that you do get a correct solution. And actually for this one as well, these are both correct solutions. Extraneous is just to remind you, it doesn't always work, so it's always worth checking just to make sure it's not one of those trick questions. And the last one, a little more complicated this time because we actually have a variable on the right-hand side as well. Same thing, I'm going to solve for the absolute value, so I'm going to subtract 1 from both sides. I'm going to divide by 2 on both sides. But at this point, rather than saying I have the positive and the negative, I need to make sure I put parentheses around the negative to make sure the whole thing is negative. And you might just want to distribute before you solve the equation on the right there. Solve each one independently. A little bit longer this time. And two answers, negative 3 and 0. Plug them back to check. And actually for this one, this does not work. Negative 3 take away 3 is negative 6. The absolute value of negative 6 is 6. 3 times negative 3 plus 3 is negative 6. So 6 does not equal negative 6. So this one is an extraneous solution, but 0 is good. Most of the time, when you find those extraneous solutions, it's going to be probably when you've got variables on both sides, but you should always check just to make sure. Now, you can also do inequalities with absolute values. I've done the regular equation up here where it just equals 0. And if you have a greater than sign, for example, then all you do is you keep the question the same, first of all. So keep the same sign and keep it positive. And on the other one, make it negative, but notice we flipped the inequality. and then you just solve each inequality independently as well. So very similar method, but you just got to be aware that you're going to flip the inequality on the one that you make negative. Now, in Algebra 2, you should also have covered some graphing of absolute value functions as well. So most people remember them basically as the V-shape. And normally what I would do is I would get students to come up to the board and actually draw these things. But as I'm going to do it from the class, as I'm going to do it from my computer, I will do the best that I can on this. Most of this is related to the translation thing, remembering what each of these things does. So +3 means it moves it up vertically 3 spaces. So I'm going to get my V shape, and it's going to look something like that. Slope of 1 because it's 1x. Next one is -2, so I know that starts from -2. I'm not going to draw the full V shape, but notice these graphs should continue up and up, but just for time. Now this one is a grouping symbol, so when it's inside the grouping symbol, it's kind of like the x minus 1. You actually do the opposite, like we did on that factor theorem, so it's actually going to start at +1 on the x-axis. And it's still going to have a slope of 1, and the graph would keep going. Absolute value of x plus 3, it's inside the parentheses, so I'm going to do, or the absolute value, so I'm going to do the opposite, and I'm going to start at -3. This time I've got a number at the start here, so that actually changes the slope. So I want to make sure I have a slope on 2, and I still want to keep that V shape though, so I'm going to make sure that one. Notice this one actually has a slope of -2. 1/3 x, so I'm going to have a slope of 1/3, rise 1, run 3, and then I'm just going to make this symmetrical and keep that V shape. Sometimes you have more than one translation, so -1 inside is going to move this, to +1, and then +2 is going to move it up 2, so it just shifts my vertex. And you might have had equations with h and k, and we'll talk about those later. +2, so I'm going to move to -2, and a -4 would be down here. And I'm just going to draw my regular old V shape in. What do we got here? Multiplication comes before subtraction using GEMDAS or PEMDAS, whatever you call it. So if I was to draw 2x, I know that has a slope of 2, but I also know I've got to move it down 5 places. 1, 2, 3, 4. I'm going to be slightly off the edge of my graph here, but this would be the correct answer, this one down here. Sometimes it's worth drawing 2. You can always erase it in pencil if you have multiple translations to actually draw. I'm starting to add in 3 things this time. So I'm going to multiply, I'm going to have a slope of 2, but I know I've also got to start from -2, and I've also got to go down 1 as well. It says, whoops, because it says -1 here. And I probably just totally messed up my graph there. Uh-oh. Hopefully the verbal description will suffice for that one. Alright, next one is very similar, thankfully, with 3 parts, so I can try a little bit better this time. So I know I'm going to start from 1, because I'm going to do my grouping symbol first. I'm going to do a slope of 1/2, so I'll go up 1 and across 2. Oh, but at the end it actually says +3, so actually I need to move this graph up 3 places. So actually the graph would look like this. Negatives at the start, that's going to be a reflection across the x-axis, so it would actually be an upside down V. I'm going to move it up 3 places. Negative with x minus 4, so I'm going to start from 4 on the x-axis, but once again I'm going to draw the upside down V. 4 parts to this technically. I'm going to do the grouping symbol first, so I'm going to start at -2. I need a slope technically of -2 as well, so that kind of also draws this upside down for you as well at the same time. Actually this says +2, so I should move this graph up 2 places as well. So we're actually looking at this second graph that I drew. Oops, that wasn't a very good arrow. And this one can get a little sneaky. It's very tempting when you see the -8 here to immediately want to go to 8 on the axis. Notice there is a common factor of 2 here though. So what I'm actually going to do is I'm going to bring the 2 to the front of the question. So I'm kind of like factoring on this question. And now I can see exactly what it looks. So actually it starts from 4 on the x-axis, which is good because I can actually see that. The slope of -2, and then I'm just going to make sure I got my upside down V. we're getting towards the end. Slightly more complicated on this one, so I'm going to start from 3 on the x-axis. I'm going to have a slope of 2/3, which I'm actually going to run out of space on this one a little bit. But also I want to move up 2 places as well, so I'm going to go up 2 and across 3. And I kind of ran out of space on this one. It doesn't fit on the graph very nicely. A lot of things on this one. I'm going to start from -1 on the x-axis from the grouping symbols. I know I got a slope of -1/3, but I also know I need to move up 2 places, so I might as well do that first. And a slope of -1/3 means I go down 1 and across 3. And then I should be able to draw in my V shape. And the last one I normally throw in, just to totally mess with people, 2 absolute value symbols, because I know that people have not seen this one before, so it's always a good one to do. Now, with grouping symbols, of course, you focus on what's inside the grouping symbols and then work outwards. So I'm just going to focus on this part here, the absolute value of x minus 2. I know that that looks like the absolute value of x, but move down 2 places. Now, this time I am going to draw the whole graph in. But that's only this part. What does absolute value itself mean, as in the ones on the outside? It means that anything that's positive is going to be negative. So this point here at -1 would have to become +1. Oops, I perhaps need to change icons here. There. My point at -2 would become +2. And my point at -1 would become +1. So actually the graph, and if I change color here, hopefully this will work fine. So this one's correct, this one's fine. This part changed. This part changed, and this part changed. So the black part at the bottom here, this would not be here anymore. It would just be the blue line. So essentially I got a W for this one. But anything that's negative, remember, we're not allowed through the definition of absolute value. Now, for questions like that are difficult, don't forget you can also make a table of values for a graph. It's probably something you haven't done since middle school, but if you ever find that question that you're not sure of, create a few values. Start at 0, probably go to 3 and to -3, and that'll cover you for most graphs. And just literally figure out what are the y values. Substitute in what is absolute value of -3? 3. Add 2 is 5. Do that for every single point and then plot those points and you can draw the graph up. And if you want to practice that, there are a few here that you could try as well. And I will quickly reveal some answers as well, if you did try. Now, I also normally give you 1 to 15. I normally give you 10 to 15 seconds to write down the equation of the graph that you see. As you can physically pause this video to save on time, I'm just going to go through them very quickly. Pause as long as you need time to actually try and write down the name of the graph. Graph number 1. Graph number 2. Graph number 3. Graph number 4. Graph number 5. Graph number 6, number 7, number 8, number 9, number 10, number 11, number 12, number 13, number 14, and number 15. And those are the answers that go with them. Any you got wrong, you might want to take a quick look back so you can try and figure out what actually happened for that. Now, earlier I did mention the h and k thing. So when you did this in Algebra 2, you probably looked at the form y equals a absolute value of x minus h plus k. So the number at the start is your slope. And remember, if a is negative, then the graph is going to be upside down. The x minus h part, it's left and right, or a horizontal translation, and it's the opposite of what you would expect, kind of like when you did the factor theorem. And then the part at the end, the plus k, that's your up and down, that's your vertical translation. So if it says +3, it moves up 3 squares along the y-axis. Now, the part that would be brand new to you, even if you did remember all this stuff, would be this. Now, the graph of 2x plus 1, I would expect you to recognize. It has a slope of 2, it has a y-intercept of 1. So start at 1 on the y-axis, rise 2, run 1, and you can easily draw a slope of 2. Now, when it comes to the other two types of questions, what happens if you have the absolute value of the whole function? And what happens if you have the absolute value just around the x? So, let's take a look at what this actually means. Now, we actually covered this question earlier because remember, the absolute value means we can't have anything that's negative. So for this graph here, this part here is just fine. So you can go ahead, and in fact this is fine as well. This is positive values here. This is like positive 1/2 here. So this part of the graph you can join in. Anything that's below the axis is going to switch from negative to positive. So this -5 is going to shoot up to +5, and that's what you can see on here. So actually what happens here is negative y values are reflected in the x-axis. So you would draw this graph, and then you would just take this part of the graph, from here, and then you would just reflect this whole line above the axis. The one where it's just around the x, absolute value, remember, makes things positive. If it's already positive, it doesn't do anything at all. So for this graph here, this part is actually going to stay the same. 0, 1, 2, 3, all these values here are going to be exactly the same. These ones here, though, these are my negative values. So my -1 value is going to be the same as my +1 value. So on my graph, it looks like it's 3. And if I do that for several points, what you get is this. So I still have my V shape, but notice what happened. I drew the right-hand side of the graph, but then I reflected that right-hand side of the graph over to the left-hand side as well. And very easy to mix these two graphs up, so make sure that you do learn these ones. Now, in regards to the exercise for this one, there is a few questions to practice with the different methods we learned so far. One thing that's always good to do, and probably not been done for a while, is your trigonometric graphs. So the graph of sine, cosine, tan, secant, cosecant, and cotangent. So you might have to go back and look at those in your notes. Basically, you're going to get those questions applying to this. So you're going to draw sine x, you're going to look what happens to the absolute value of sine x, and then you're going to look what happens to sine of the absolute value of x. And you're going to apply these two rules that you can see on the bottom. And this will actually be the sheet that you're going to work on. The first two questions come from the textbook, and then the last questions are ones that I actually made up myself, because I need you to go back and look at those trig graphs, because I know otherwise you probably won't look at those again, and that's something you can easily forget. And then on the bottom, I show the question that you won't have seen before from Algebra 2, just to make sure you understand what those properties actually do. So drawing quadratics, and then drawing the absolute value of quadratics as well. That should do it for this video. As always, go practice now. That's what you need. If you need additional help, my links to my YouTube page are below, and that'll do it for this video.